I'm Mark Fletcher, Avaya Chief Architect for Worldwide Public Safety Solutions, and this is Enterprise 911, Emergency Communications and Response. On December 1st of 2013, Carrie Hunt Dunn died because of a single digit. Carrie met her estranged husband in a Marshall, Texas hotel for visitation with her 3 children. During that visitation, her ex-husband brutally attacked and stabbed her 49 times in the hotel room bathroom. During the attack, her 9-year-old daughter tried to call 911. In fact, she tried to call 4 times, but unfortunately, the calls failed. Finally, she rushed her 2 siblings to safety, but Carrie Hunt Dunn died from her injuries before help could arrive. Why did the calls fail? You needed to dial 911 from the hotel room. But that's not what we teach our children. This is why the No 9 Needed campaign was started. We teach our children that in an emergency, you call 911. The National Emergency Number Association estimates that there are over 270 million calls to 911 each year in the United States. The California Public Utilities Commission reported that potentially 80% of enterprise MLTS PBX systems need some level of 911 remediation work. Next Generation 911 will eliminate the need and reliance on the legacy Annie Alley telephone number and address database. For MLTS, there are 3 basic concerns for 911 call processing: access to 911, notification of 911, and reaching 911. In the United States, the legislative landscape is as follows. There are currently 18 states that have a reference to multi-line telephone system PBXs, but the laws vary greatly, which causes a lot of confusion. In Chicago, the level of granularity of reporting is 40,000 square feet. Massachusetts dictates 22,500 square feet. Virginia requires 7,000 square foot granularity. And the pending legislation in California is based on fire alarm zones. Several years ago, the Federal Communications Commission issued a notice of inquiry asking about location discovery practices in MLTS PBX systems. Both Avaya and the National Emergency Number Association responded to that notice of inquiry, stating that MLTS location capabilities are feasible, and the FCC should begin a proceeding to establish a time frame for mandatory implementation. The recent legislative driver has been Carrie's Law, as noted here by the statement issued by Commissioner Pai on January 13th of 2014. Key dates on the timeline behind this are the December 1st murder of Carrie Hunt in her Marshall, Texas hotel room. On December 20th, it became mainstream news and was covered in my blog on avaya.com. On December 27th, I issued an open letter to the FCC, bringing this to their attention. And on January 2nd, I made contact with FCC Commissioner Pai's office to schedule a meeting. That meeting occurred on Friday, January 10th in Washington, D.C., and the following Monday, on January 13th, Commissioner Pai issued a statement on the importance of connecting Americans to emergency personnel whenever they dial 911, as well as issuing a letter to the top 10 hotel chains. 4 days later, on January 17th, the American Hotel and Lodging Association formed a special task force to investigate the problem, and we've been in contact with the AHLA to help them assess the problem. Commissioner Pai has made several public statements regarding this that have significantly helped the cause. The most important question a caller can answer is still one of the most basic: where are you? Next Generation 911 doesn't mean that we can ignore the problems with the legacy 911 system of today. One of those problems happens too often when someone dials 911 in places like hotels, motels, office buildings, and schools that use an MLTS. I began an inquiry into the state of MLTS 911 in January of 2014. I sent letters to the CEOs of the 10 largest hotel chains. And finally, I hope that the FCC can make those choices a little easier for you by the FCC fixing the problems of 911 on MLTS. Let's take a look at the anatomy of an E911 call in the PBX and understand how it works. While this process is specific to Avaya PBX systems, the general principles are applicable across many other manufacturers. A user dials 911 or 9911, and the automatic route selection catches that call and processes it. IP devices are matched against an internal IP subnet map where their location is determined, and based on that location, an emergency location identification number, or emergency location number, is assigned as caller ID to that phone call. The call is then sent to telco with that caller ID, where they validate it and it becomes ANI, or Automatic Number Identification. The automatic number identification is then matched against the Master Street Address Guide, which determines the proper 911 public safety answer point that the call needs to be routed to. The call is then delivered on special 911 trunks as voice and ANI in band. Specialized equipment at the public safety answer point extracts the automatic number identification and performs a database query against the telco ANI-ALI database, where that location record is then retrieved and displayed to the call taker as a screen pop. But wait a second, how does the enterprise location data get to the PSAP? That step was missing, wasn't it? Well, in fact it was. So how does enterprise data get to the PSAP? Simple, it can't. Let's take a look at the process and try to understand what's supposed to happen. The enterprise location database exists, as does the ANI-ALI database located at telco, and often some level of automation is deployed in the middle to synchronize those two databases, so that when the 911 call taker accesses the ANI-ALI database, information is there waiting to be retrieved. In the enterprise network, a user is located at a specific location, and that registration event is picked up by the automation software, which then takes that information and places it in the ANI-ALI database. When the user makes a 911 call, and that caller ID or ANI is presented to the PSAP, that phone number is used to initiate a query into the ANI-ALI database, which then retrieves the record. Now, when all of those steps happen, the information flow is secured between the origination point and the terminating point. But let's take a look at what typically happens. Once again, our user is located in the enterprise location database, and our automation technology moves that information into the ANI-ALI database, waiting to be retrieved. When the user makes a 911 call, either improper programming in the MLTS PBX sends the main billing telephone number as caller ID, or potentially the telco doesn't honor the calling line ID sent and replaces it with the billing telephone number, which creates a problem because now when the PSAP makes their database query with the main billing telephone number, they get back the main billing address, and not the individual station record that was assigned. This is why we talk about location granularity externally. What level of reporting is actually needed at the PSAP? Since a dispatcher's job is to primarily dispatch, they need a response address, or in a large enough complex, a building entrance identifier. Enterprises should concentrate on getting the 911 dispatcher the details that they need to get responders en route to the scene. Not only is station-level granularity irrelevant at this stage of the 911 call, it becomes difficult to manage and costly. For an individual station to have an ALI record, it has to have two things: a telephone number and a PS-ALI database entry, both of which are recurring monthly costs and require an application in the middle to manage the data. The additional piece of this is that the ALI database only provides a single field that's 20 to 30 characters in length that the enterprise can populate with additional data. In most cases, 20 characters is not sufficient to convey information to the PSAP. This information, although detailed, means nothing to first responders, who've most likely never been in the building before, and local on-site awareness is still required to direct responders to the scene. While emergency responders absolutely need usable location details, that information is not typically relevant until they arrive at the correct address. This is where we focus on enterprise location granularity internally. Enterprise environments can utilize additional call handling technology that already exists to aid in response by designated first response teams, building security and EMS, or any other authorized group or individual. Localized data that can be provided includes floor plans, hazmat information, or even IP video feeds. And when public safety first responders arrive on scene, that information can be easily handed off to them, while in the meantime, localized responders can be addressing the incident. One of the questions most customers ask is, what is the PBX E911 functionality? What's built in, what's not, and why? The basic built-in functionality that's included, and we promote as Carey's Law, is direct access to 911 both with and without the trunk access code. On-site notification, alerting to devices and individuals that an emergency call has occurred and from where. And the third is not as much of a feature, but a best practice. Do not answer your own 911 calls unless you have a trained staff to do so that provides the same level of service that an emergency medical dispatcher does. All calls to 911 and 911 should egress your system and be delivered to the 911 public safety network. Enterprise networks do pose some problems, location discovery being one of the most important. Understanding where an emergency is occurring is the key piece of information required to provide assistance. Device mobility can add complexity to any environment, and almost any device can be nomadic. TDM devices can use virtual office. Voice over IP devices allow users to move themselves. And wireless LAN telephones are inherently mobile. Plus, most companies today offer remote teleworker solutions to their employees, which creates a nomadic VPN challenge. But enterprise MLTS PBXs can provide some basic level tracking, including on-site notification, proper call routing, and appropriate caller ID or ANI manipulation. So what E911 functionality is really required today in the enterprise? We believe the main thing is data correlation. Fletch just made a 911 call. Someone needs to go see if Fletch is all right. But in the future, we'll know that Fletch just made a 911 call and the ambient temperature near Fletch is 227 degrees. The correlation of that information means that someone still needs to go see if Fletch is all right, but someone needs to go see if Fletch is on fire. There are other problems that need to be solved in the enterprise, and one is a VPN worker. When a user connects to your network from a remote location, routing becomes a challenge. So Fletch just made a 911 call from his VPN phone at home. The problem is Fletch is 3 states away, and we have no trunks there. With proper remediation of 911 in your network, you'll know that Fletch just called 911 from his VPN phone. And you'll know that Fletch is not on the corporate LAN, and therefore needs to be routed to a voice over IP positioning center for 911 services. Oh, and someone still needs to see if Fletch is on fire again. So you can see that the real issue at hand is identifying the problem. In addition to the PBX having data, what about LDAP, HR databases, directories, maps, and cable plant information? This is all valuable data that already resides in your enterprise network and can be utilized in conjunction with the PBX data to identify where an emergency is located. Does mail get delivered to your cubicle? Well, chances are you already have the information you need to locate someone in the building. Let's talk a little further about the cloud and what I call ECAS, or Emergency Communications as a Service. You may have been told that the cloud is the way forward for everything, so why not E911? Isn't everything going to be that way in the future? Can or should E911 be a completely hosted 911 solution? My immediate answer to that is no. Phone numbers don't equal location anymore, and managing the ALI database is yesterday's technology. On-site E911 notification belongs on premises. Don't get that part confused by the cloud. If your entire solution is cloud-based, the call needs to get to the cloud, and then the cloud needs to get back to the enterprise to provide that on-site notification. Now, while the cloud may very well be a part of the solution in many scenarios, it still requires some local presence for notification and alerting. And planning and consulting workshops are available from Avaya and our channel partners to help you determine what's right for your environment. Since you'll probably be looking at cloud-based 911 VPCs, you should understand the architecture. There are primarily 4 Tier 1 voice-over IP positioning carriers in the US: Intrado, Level 3, Bandwidth, and Telecommunications Systems. These carriers provide minimal differentiation in the level of service, all have a common feature set, and it's important to understand that currently no one carrier provides 100% coverage. But 100% coverage can be achieved by using multiple Tier 1 VPCs. This is where the Tier 2 VPCs come into play, and there are several in the Avaya DevConnect Select product program. The Tier 2 providers are Tier 1 aggregators and provide valuable services like consulting, teleworker dashboards for your remote workforce, and data normalization services for your entire network. There is significant service differentiation in what they offer, and there are variable deployment cost models that you should become familiar with. This is where you need to evaluate the features and the costs carefully. Sitting below the Tier 2 players are the Tier 3 resellers of rebranded Tier 2 services. Now, typically these are service resellers with limited value proposition, and they're not typically commercial enterprise plays. You'll find these offered by distributors, hosted PBX providers, and cable and internet voice-over IP services. Remember, these are just typically rebranded Tier 2 services. So why put another layer of complexity between you and the emergency services network? Another common thing to watch out for is a single point of failure in a 911 design. Not all solutions are created equal, and you need to carefully watch for applications that are in the call path that could potentially block 911 calls. There's a big difference between redundancy and call admission control. Redundancy describes components that are installed as primary and backup resources in case of a failure. When the primary is down, the PBX will route to the secondary. Call admission control works a little differently and is sometimes called look-ahead routing. Calls only proceed if they can complete to the destination. So if you have an E911 gateway that's in the call path and it's offline completely, the Avaya ARS will route to the secondary instance. But if there's a soft failure and the northbound interfaces are out of service, but the PBX still sees a valid circuit, then calls may black hole. This is because the PBX is unaware of the northbound failure. Call admission control allows upstream problems to shut down the interface. This is critical to preventing the black hole scenario. You should be aware that DevConnect does not test for call admission control. The Avaya DevConnect program uses system integration lab notes for each tested product. These detailed notes explain the exact scenario used by the Avaya DevConnect engineers to verify the application and its operation. Call admission control is not currently part of the SIL notes for any E911 product in the path of a call for E911. Customers should be aware and conduct the appropriate level of testing for their specific network configuration. As a summary, let's look at what we just talked about in 4 simple slides. What we're trying to do is get additional information to the 911 responder. Unfortunately, in-band is not supported today, as it's an analog voice-only architecture. It's not possible today because the PSAP technology is limited to ANI and ALI. And it's not feasible today because the amount of bandwidth required to stream that data is just not available on a voice circuit. What we can do today is deliver simultaneous local notification to on-site personnel that's easily delivered on-site. It's also easily delivered over broadband or over the top of the existing 911 network. That solution is available today, provides rich multimedia access, and can be delivered to anyone through a web browser. Once again, 3 basic built-in system requirements. Direct access to 911 with and without a trunk access code. Local on-site notification or crisis alert, alerting to devices that an emergency call has occurred and from where. And the internal termination of 911 dialed calls, prohibited unless it's a trained facility with trained personnel. Some other best practices for your deployment or must-have features? No single point of failure. Full support for the emergency services functions that are built into the call server. Devices and applications must connect via an approved and supported interoperability point as defined by the Avaya DevConnect program and product managers. And the vendor should have a defined roadmap to next-generation 911 integration that's in alignment with the NENA 08003 v2 requirements with support for additional data repository, ALDR, and ACDR functionality. So that when next-generation 911 is available in your area, you're not looking to upgrade your 911 again, you're just looking to turn on a data feed that's already there. If we look at the next-generation 911 architecture, what's missing? Because we're delivering detailed location information via SIP with the call, the ANI and ALI databases are no longer required, nor is their management and monthly fees. Remember, the data that PSAPs want are things like floor plans, environmental data, video feeds, hazmat material safety data sheets, or even personal medical information if opted in by the user. Whatever solutions customers buy today needs to be in alignment with this new role in the future. Don't end up buying somebody's legacy fire sale technology. Remember, E911 is not just a box. Set it and forget it might work for Ron Popeil, but it's not applicable to E911 solutions. 911 partners offer various solutions for E911, and their methodologies widely differ. Making the final technology selection is a very specific decision for each and every customer that's based on needs. The challenge that most customers have is that they can't articulate what those needs actually are. Because of this, they typically underbuy or overbuy, buy the wrong technology, and this ends up in poor customer satisfaction and, quite frankly, a poor reflection on Avaya. For more information on Avaya 911, you can check out my blogs at avaya.com/Fletch911 or my general industry blogs at avaya.com/Fletcher. And most of our content is available as a podcast at avaya.com/APN. Thanks for watching, and thanks for making your enterprise MLTS PBX environment safe for your customers and employees.